So if I'm looking at a pyramid, something to keep in mind is the base on a pyramid can be pretty much any shape. So you have to keep that in mind, okay? So this one is, it's hard to tell. It's probably a rectangle. It could technically be a square, but I could have a triangular base. I could have a hexagon base, like pretty much any option, okay? So what we do for the surface area is we're going to do the base area. So remember that could be anything, plus the triangles area. Where is triangle coming from? Where are there triangles on that? Each side is a triangle. Sometimes those will be congruent, but not always. So what shape would the base need to be for all of the triangles to be congruent? Square, right. So if it's a square, you can just do like times 4. If it's rectangle, I could do 2 of one, 2 of the other. So you got to keep, this part can be kind of tricky figuring that out, okay? Something you probably haven't seen a whole lot. The slant height, so it has an L here. Sometimes they'll write it like this too. Will be the height of the triangles. So I'll draw a little picture here for you. So like that side there. So it has this line going. This right here, that is the height of the triangle. Okay, and then you'll still do it times the base, which is going to come from that base measurement. Okay, so like if I was looking at that flat, it would just be the height of the triangle. All right. Cone. So 3D pyramid, sort of, but it has a circular base in this case. So since it's circular, it doesn't have those triangular sides. So your formula is pi r squared, oops, because that's the circle, okay? That's the circle base, plus, and then this is the side. Oh, I forgot I wrote that down here. So the circle base, pi RL, represents the sides of the cone. Okay, a sphere, so think like a ball, is 3D solid in which each point is equidistant from a center point. So that just basically means like the radius could be drawn anywhere, okay? So like all of these distances are going to be the same. So what you do for that is 4 times pi times r squared. So it's really similar to just the formula for area, okay? But it has that 4 added on. Okay, and now a hemisphere. How much of a sphere would a hemisphere be? Half. Okay, so you might think that this number down here would end up being a 2, but the thing is, if you look at this, so the outside, a sphere, only the surface area is just all this around here, right? But for a hemisphere, it has that half of that, but it also has this circle added in. So it's kind of like adding a 1 to a 2, making it a 3, okay? Because the sphere doesn't have this circular part that you're including. It doesn't have a flat part. All right, so let's just take a minute here and classify these 3. So on the part down here where it says classify, just want you to write what shape. On number 1, you do need to write what shape the base is. So for a pyramid, like if it's a triangle base, I would say triangular pyramid. So this one, find what shape the base is, classify each of those. Okay, who thinks they have number 1? What would I name this one? Nolan, what would I classify number 1 as? What kind of pyramid is it? What shape is the base, though? Rectangle. So make sure you have this. It is a rectangular pyramid. All right. 2. Brendan, what's 2? Okay. What shape is the base? Okay. What does it look like if I would put ice cream on top of that? It's called a cone. So just a cone? Just a cone. Yeah. You won't have different base shapes on a cone. That's what kind of sets it apart from being a pyramid, is it has a circular base. Okay, and then 3 is a what? Sphere. So remember, when it's the half one is when it's the hemisphere. I think H for half. Hemisphere, half. Okay, so I want you now to just take a minute and write each of the formulas. So what I mean by that is this. Actually, on number 1, we don't really have one, so I'll do that one with you, then I'll have you write them. Okay, so number 1, since it's a pyramid, we're going to do the base area plus the triangle areas, okay? So this one's not a set formula, but let's look at the base. So this is the base. It is sitting on the bottom. There will be how many of those? 1. So like last time we were having 2 with the prisms. This one may not have that with the base. What are the dimensions of that base? 9 by 4. And that's it, because it's a rectangle. So 9 by 4 gives us what? An area of 36. Circle that. Okay, now we need to do the sides. Are they all 4 going to be congruent? No, because we have different side measurements. If I'm looking at this front one, okay, how many will there be of that one? 2, because there's one at the front and at the back. So I'm going to write a 2. Triangle formula, what is it for area? What makes it different than for a rectangle? It's really close. I have base times height, but what else? Half or 0.5. So 1/2 times, what is the base of that triangle? 9. Now the height, remember this will be the slant height. So it has to measure along the front here and touch at a 90. So they do give it to us. It's 7.3. Sometimes they don't. Okay, and then you can take all of that times 2. You don't have to put parentheses. I was just showing like when you're done, you can. Okay. McKenna, what'd you get? Yes. That was for both of them because we already did the times 2. Okay, I have done 3 faces. How many faces are there on this? 5. So I need to do 2 more. So we need to do the sides. Okay, so without looking up here, because I'm going to write it up here. If you're really stuck, then you can. But try to figure those 2 triangular sides on your own. All right. Kyle, what'd you get? Yes. Did everyone get 33.2? All right. And then last step, I have 5 faces, which is correct. And then now I just add them all up, same as we did last time. Alex, did you get that?
Yeah.
What'd you get?
134.9.
Good. 134.9 kilometers squared. It's a really big pyramid. All right. Cone. Do we have a formula for this one? Yes, so copy it down. SA equals, remember you can either look on the back or you can zoom up here. The first part I just remember, well, it's the area of the circle, so it's pi r squared. And then the sides are pi r L. Remember, L is this measurement along the side. So 20.1 will be my L. Is 9 my radius? Yes, because it is halfway. So pi r squared plus pi r L. So I would write that before we plug in, just to kind of help you memorize. Okay, so then pi times 9 squared plus pi times 9 times 20.1. So this one, there's nothing for us to like figure or find. There wasn't a missing part, so you can just plug all of that in. Brendan, do you have that? All right, what'd you get? Yes, I got that too. 822.8, is that what you guys got? Good. Feet squared. Okay. All right, what is the issue with 3 before we start on it? What's the problem with the measurements they gave us? I only have the diameter, so what would the radius be? 8. Okay, we do have a formula for this one. So remember, it's 4 pi r squared. So SA equals 4 pi r squared. So I'm going to do 4 times pi times 8 squared. Matt, let me know what you get on this. So 804.2 centimeters squared. Okay, so we're good on this page. Flip the page. Okay, and then take a minute on 4, 5, and 6. Again, I want you to classify them. Careful on 6. So you're going to need to count the sides of the base on 6. See how many sides there are to name that. Okay, so do like 30 seconds there or so. So fine. Gabe, what was 4? What shape is 4? Oh, yeah, I'm sorry, I didn't hear you. I thought you said, Okay, 5, so it's half of a sphere, which is called a what? Hemisphere. All right, who has 6? What shape was the base? Leah? Okay, so hexagonal prism, good. I'm going to shorten that sound, or not prism, pyramid, sorry. I don't think I can fit that. So hexagonal pyramid. It was 6 sides. I always remember there's an X in both of those. All right, now for the surface area. Bless you. So 4 has a formula. Okay, so let's write the formula just to help you kind of memorize it. So I do the area of the base. Alyssa, did they give us the radius here? No, so what would the radius be? Good. So I do pi r squared plus pi RL. So pi times 5 squared plus pi times 5. Do we have the L? What's the L? Yes, remember that's the slant height. So if you measure along the outside of the cone, what shape is that? Sometimes they're going to give you the direct height, which will go down to here. And that is a little different. Okay, so type all that in. Does anyone already have that? Yeah, what'd you get? Did you get 254.5? Yes, me too. So when you type all that in, 254.5 yards squared. Okay, I want you guys to try the hemisphere totally on your own. Let's do 1 minute. So we did SA for hemisphere. We do 3 times pi times 5 squared, which gave us 235.6 kilometers squared. All right, so the last one of these basic ones here is 6. Remember, pyramid doesn't have a set formula. We just have to do the area of the base. So always start with that, so that's just kind of out of the way and done. Okay, so if I do the area of the base, it is what shape? Hexagon. So if you can draw that quickly, do it. If not, just write hex, whatever you want to do. Okay, so we got to think back here a little. Area of a hexagon. Look on your formula sheet at the back. What formula would you actually use for that? Because it doesn't say area of a hexagon. Area of a polygon. Good. Anything 5 and over, we use that. So that is 1/2 times what? A and capital P. So then I will do 0.5 for half. Okay, A stands for apothem or apothem. It's debated on how to say it. That is, it's kind of like the radius, but it's drawn at a right angle from the center. Do we have that number? Yes. What is it? Good. All right, now the perimeter, if I put times 6, this answer will be wrong. Why is 6 not the perimeter? One side. So what should I take 6 times? 6. So that's why knowing that it's a hexagon was important, okay, because we need to know how many will I multiply that by. So multiply that out real quick. I got 93.6. Did you guys get that? Okay. So I only have 1, so I'm going to circle it because I know I need to come back and add it later. So pyramid kind of falls into those ones where you have to add the sides where we don't have just that set formula. This makes it a little trickier. All right, now pause, and before you get started, just pause and look here for a sec so I know you're focused here. The triangles. I will tell you they will be congruent on this, but how do I know that? David? Yes, so the circle is specifically telling you the angles. Right, so he's saying the angles are all the same, so the sides are all the same. That would work. Anything else that tells me? Leah? Congruent markings here. Okay, so those will be on there if they're all congruent. So really, I only need to find the area of one triangle and then do what with it? Multiply by 6. Good. So let's do triangle. I'm going to write a 6 in there. Okay, so area of a triangle. What's the formula for area of a triangle? Half base times height. So if I look at that triangle, so I'm going to look, focus on this one if it helps you to like kind of write it. What would the base be? So right here is what? 6, because it's congruent. Remember, these are all congruent, so I can use the measurement that they write on any of them, okay? Base would be 6. I need this slanted height here. What would that be? 3.1. So I'm going to do times 6 times 3.1. 13.1. Sorry. Thank you. 13.1. Make sure you correct that. Oh. And then we're going to take our answer times what? 6. So half of 6 times 13.1 times 6. Corbin, what'd you get? Yeah. Okay, so I have figured 7 faces. Is that right for a hexagonal pyramid? Because it'd be 6 sides, right, and then the base. So don't forget about the base, so it actually puts it at 7 faces. All right, so add them together. And I got 329.4. You guys agree with that? Okay. Okay, hard ones for last, of course. I'm going to put a little star on number 7. What do you think that means? Yes. There is a very similar question on the quiz, which will be next class. It's over lessons 7.1 through 7.3, okay? So I want to make sure that if you have any questions on this one, please make sure you let me know, because you're going to see this one again. So it's a what shape, first of all? What's the top one? We have 2, right, because it's a composite. What's on top? What? Cone. All right, let's start with that then. It's kind of hard to draw. Yeah. Okay, I want you to write the formula for surface area of a cone. It is what? Area of the base, so pi r squared plus pi r L. Okay, please don't start yet. Pause and look here. Remember surface area we talked about when it's composite. That was where I said if you like dip it in a big thing of paint, what part doesn't get covered? So what is not exposed here? What's not going to count as being exposed to the surface area? The bottom of that cone. So what can I take out of the formula? The circle, which is which part? First half or second half? First. So mark that off. That is not exposed. Does that make sense? Questions there? You can go back later and subtract it, but it's definitely a lot easier to take it out now, okay? So either way. All right, so now we're just doing pi r L. So pi times, what's wrong with 8? Diameter. So I need r equals, I heard someone say 4. Good. And times, what would L be? 12. So pi times 48. Or 48 pi. Okay. I got 150.8. Agree? All right. All right, so that's the cone part. So I'm going to circle that because I'm going to need to add it later. All right, now the shape on bottom is what? Hemisphere. So the formula for surface area of a hemisphere is what? What was the first thing you said? 3. Okay, but again, pause and look here. There are 2 ways you can do this. Where did I tell you guys that 3 came from? A sphere is 4, right? So why is it, if it's just half, why is it not just 2? Right, the circle. So I'm adding that like 1 back in kind of. So I could either do this as like 2 pi r squared, or I can subtract out the circle. I don't remember what I did initially, but so let's do both ways here. Let's try this first. So 3 times pi times 4 squared. 150 point what? Oh, same as above. Okay. What would I do to subtract the circle though? Like, do I have the circle? Do I have just the circle? So let's do the circle real quick. So it would be pi r squared, pi times 4 squared. I got 50.3. Did you guys get that? Yeah. Okay. Okay. So I could do what with those, I said? I'm not including the circle. So what would I do with it? Subtract it. Okay, so that would give you what? 100.5. Okay, now let's try the other way. So this is option 1. Option 2, I said the 3 comes from you're adding the circle back into a hemisphere. But if I'm not adding it in, a sphere's surface area formula is just 4 pi r squared. What's half of it? 2 pi r squared. 2 times pi times the radius is 4 squared. So do that real quick. What'd you get? If you haven't already typed it in, please do so real quick. 2 times pi times 4 squared. 100.5. Did we come to the same answer? Yes. So either option will work on that, okay? But you just want to think about what makes most sense to you. I typically do this one. like sets either. All right, so final, I already circled this one. I don't want to circle these twice, right? Because they're the same thing. So just circle one of them, and now we do what with them? Add them up. We can maybe do that in your head. So Dixon, what's 150.8 plus 100.5? No, close. 251. There you go. Forgot to carry. Okay. All right, so a lot going on with number 8. So last one here, though. So we have 3 shapes making up number 8. All right. What's on the left side? We'll work left to right. What shape is this? Cone. All right, so we have a cone. Start with that. Why is there only one of those? Like, why is it not the same as the other side? Their slant height's different. Perfect, yes. So this one has 3, this one has 4. So be careful, because when I initially looked at that, I kind of thought they look pretty close, which makes sense because 3 and 4 are pretty close, but not exact. Okay, so what is not showing, though? So if I do all of this, if I do pi r squared plus pi rl, why would my answer not be right? The circle's not showing, so X that off. So I'm doing pi. Do we have the radius? Yes, because since it's part of that cylinder, their circles are congruent, just not their height. So pi times 2. If we're on this left side, what's the slant height? The L. 3. Okay, so 6 pi is what? 6 times pi. Alex, what'd you get? 18.8. Okay. 18.8. So do that. Okay. You guys take a minute and try this other cylinder. Or cone, sorry. So do the other cone, then we'll do the cylinder together. All right, so you should have done pi. The radius was still 2, but the slant height on this one was 4. So pi times 8 is 25.1. Do you guys get that? Okay. All right, now what is left for us to figure? The rectangle. Yeah, it's actually, so it's a part of the cylinder, right? But why are we not going to include, so surface area of a cylinder is 2 pi r squared plus 2 pi r h. So remember this part, the left side there, and I flip those sometimes, sorry. I don't know. It doesn't matter because it's addition, but this part goes with the what? Does it go with the rectangle or the circles? The circles. Because there's pi r squared is area, there's 2 of them. This goes with the rectangle. What part am I not including on this shape, though? What's not showing? The circles. So I want to mark that off. So that's the hardest part with composite, is what part do we not include. So I'm going to do 2 times pi. Radius is still 2. What would the height be, though? This cylinder is laying on its side. 3. So 2 times 3 times 2 is 12. So you're going to do 12 pi. 37.7? Yeah? Okay. All right. Am I going to need to subtract anything out on this? No, because I already kind of did. I just didn't include it. So final step would be to add them up. All right, so when you are done, raise your hand. I will check it and give you your homework. Please remember, there is a quiz next class. A lot of people are missing 7.2. So if you need to take a minute and do that today, I would really, really try to have the first 3 homeworks submitted by the quiz next time, okay? Just for kind of make sure you've got a grasp on it, okay?